You ever just look at your phone or your headphones or really any gadget you own and think, how in the world was this actually made? How does a simple spark of an idea become a real physical thing you can hold? Well, today we're going to break down that entire journey. Look, every awesome product starts as just an idea, but it's not magic that makes it real. There's actually a very clear roadmap, a really creative and collaborative process that takes that initial thought and turns it into something you can actually use. So, what is that roadmap? Well, that's exactly what we're diving into. We're going to walk through the 7 essential stages of electronic product development. This is the modern pipeline that turns pure imagination into a manufactured reality. So, this right here, this is our guide for the journey. It all kicks off with a design concept, then it moves logically through planning all the electronics, building out a prototype, testing it, until finally it's ready to go. This is the path from thought to thing. Now, the engine driving this entire process is something called computer-aided design, or CAD. Think of it as the universal language of modern engineering. And for the products we're talking about, this language splits into 2 crucial dialects, one for the product's brain and one for its body. Let's start with the brain. We're talking about designing the product's electronic nervous system, all the smarts inside. And this is the domain of a special kind of software called ECAD. So, ECAD, which stands for Electronic CAD, is basically the digital workbench where engineers build all the circuitry. They design what's called a schematic, the blueprint for every single electronic connection, and then they lay out the printed circuit board, or PCB. That's the physical green board where all the chips and components actually live. This whole process breaks a super complex job down into simple steps. You draw the circuit, you define all the parts. But here's the really powerful part. You can run checks that automatically find mistakes, and you can even simulate the circuit to see if it'll work, all before a single physical part ever gets made. Okay, so theory's great and all, but let's make this a bit more real. We're going to see how these steps actually play out in a real-world software tool, Autodesk Fusion, to lay out a PCB. This is where that digital blueprint for the electronics really starts to take shape. So the process unfolds in 4 main phases. First up is schematic capture. That's basically drawing the circuit. Then you move to board layout, which is like digitally arranging all the components on the virtual board. After that, it's time for routing, where you draw all the tiny copper wires that connect everything. And finally, verification, running a design rule check to make absolutely sure the board can actually be manufactured without any problems. All right, so we've got the brains of the operation sorted. But what's a brain without a body? That's where we flip to the other side of the CAD world, building the mechanical skeleton and skin with MCAD. MCAD, or Mechanical CAD, is all about the physical world, the stuff you can actually touch and feel. This is the software you'd use to design the product's plastic case, or maybe some metal heat sinks to keep it cool, and all the little brackets and supports that hold the whole thing together. It defines the product's shape, its size, and how it feels in your hand. And this is what you get, a super detailed 3D model of the product's enclosure. With MCAD, engineers can see exactly how every little piece fits together, the case, the buttons, the circuit board, long before they spend a fortune on expensive manufacturing tools. But here's where the real magic happens. The most critical step in modern design is bringing these 2 worlds together. By integrating the electronic design and the mechanical design, engineers can make sure everything fits perfectly. Honestly, this tight integration is the secret sauce behind the sleek, compact devices we all use every day. But a great design isn't just about looking good and working well. It also has to be something you can actually build efficiently. And this brings us to a really crucial modern philosophy, design for manufacturing, or DFM. This slide shows such a huge shift in thinking. The old way was like a relay race. Designers would finish their work and just toss it over the wall to the factory folks, only to find out way too late that it was too expensive or complicated to actually build. The modern DFM approach? It's more like a soccer team, where design and manufacturing are working together, passing the ball back and forth from the very beginning. Now, this collaborative approach actually has a name. It's called concurrent engineering. And it just means that instead of thinking about problems one after another, all the key things, the design, how it's made, its quality, its cost, are all considered at the same time, right from the start. So why does all this matter? Well, the payoff is absolutely huge. By designing for the factory from day one, you slash development time, you lower costs, and you avoid those super stressful last-minute design changes. And ultimately, what does that mean? It means a higher quality, more reliable product ends up in your hands. So, the digital design is done. It's been optimized for manufacturing. Now for the really fun part, turning all of those digital files into a real physical object you can actually hold. And here we are, stage 5 of our roadmap, the very first prototype. This is that magical moment when the design finally leaves the computer screen and takes physical form, usually through cool technologies like 3D printing or CNC machining. From here, things really start to pick up speed as we head for the finish line. In stage 6, that prototype gets put through its paces, rigorously tested and refined. And once it's perfect, stage 7 is all about getting ready for scale. That means generating the final manufacturing files that tell the factory exactly how to build thousands or maybe even millions of these things. And there you have it, from a simple idea through the digital worlds of ECAD and MCAD, all the way to a physical product ready for the world. This is the exact process that built the technology all around us. So the only question left is, what is it going to build next?